Hello everyone, welcome to Zoom in Data. In this DP 600 course, you'll learn Microsoft Fabric from an analytics engineer's perspective, focusing on data modeling, DAX, performance optimization, governance, and building end-to-end analytics solutions. This series is designed to help you prepare for the interview while gaining practical, real-world skills. At Zoom in Data, we simplify complex data concepts through clear, structured learning to help you grow faster in your data career. Microsoft Fabric brings together data engineering, data integration, data warehousing, real-time analytics, and business intelligence in one platform. The key concepts covered throughout the course work together to build complete and scalable analytics solutions. Understanding how different Fabric components connect is more important than memorizing individual features. This final review brings together the major architecture, modeling, performance, security, governance, and reporting concepts. Microsoft Fabric provides an integrated analytics platform where multiple workloads work with a common data foundation. OneLake acts as the unified logical data lake for storing and accessing organizational data across Fabric. Different workloads such as Data Factory, data engineering, data warehouse, and Power BI address different stages of the analytics lifecycle. Understanding OneLake and Fabric architecture helps determine how data should move through an end-to-end solution. A lakehouse combines flexible data lake storage with analytical capabilities and is well suited for engineering and mixed data workloads. A Fabric warehouse provides a SQL-focused environment for structured relational analytics and business reporting. Delta Lake provides reliability features such as transactional consistency, schema management, and support for efficient data operations. Choosing between these technologies depends on data structure, workload requirements, analytical patterns. Medallion architecture organizes data into bronze, silver, and gold layers based on increasing levels of refinement. Bronze generally stores raw data, silver contains cleaned and standardized data, and gold contains business-ready analytical data. Data flows Gen 2, Power Query, pipelines, notebooks, and SQL can support different transformation requirements. A structured transformation process improves data quality, traceability, reuse, and reliability across the analytics solution. A well-designed semantic model provides a business-friendly structure for analyzing data through reports and dashboards. Star Schema design uses fact tables for measurable events and dimension tables for descriptive attributes. Data granularity defines the level of detail stored in a fact table and should be selected carefully during model design. Correct relationships, role-playing dimensions, many-to-many handling, and slowly changing dimensions help represent complex business requirements. DAX provides the calculation language used to create measures, calculated columns, and analytical expressions in Power BI semantic models. Row context evaluates calculations for individual rows while filter context determines which data is included in a calculation. Calculate is a key DAX function because it modifies filter context and enables powerful analytical calculations. Time intelligence, ranking, aggregation, debugging, and performance optimization are important areas for advanced DAX data. Import mode provides fast in-memory analytics, while direct query can be useful when data needs to remain at the source or freshness requirements are important. Composite models allow different storage approaches to be combined when a solution requires additional flexibility. Vertipack compression, cardinality management, aggregations, and efficient model design are important for improving analytical performance. Performance Analyzer and other diagnostic tools help identify slow visuals. Effective reports transform analytical data into clear visual information that supports business decisions. Report design should focus on meaningful KPIs, appropriate visualizations, logical layouts, and clear navigation. Interactive features such as slicers, drill down, drill through, tooltips, bookmarks, and field parameters improve data exploration. Good dashboard and report design presents important information clearly without unnecessary visual complexity. Fabric security controls determine who can access workspaces, items, reports, models, and underlying data. Workspace roles, row-level security, object-level security, and appropriate permissions provide different layers of access control. Sensitivity labels help classify sensitive information, while governance practices support ownership, quality, discovery, and compliance. Data lineage and impact analysis improve transparency and help teams understand dependencies before making changes. A complete Fabric solution connects ingestion, transformation, storage, modeling, reporting, security, governance, and monitoring. Exam scenarios usually provide requirements and constraints that must be matched with the most appropriate Fabric feature or architecture. Focus on important clues such as data volume, freshness, performance, security, transformation complexity, and user requirements. The best answer is usually the solution that satisfies the stated requirements without complexity. Microsoft Fabric combines data integration, engineering, lakehouse, warehouse, semantic modeling, Power BI, security, governance, and analytics capabilities into one platform. Strong solutions depend on good architecture, reliable data transformation, effective modeling, optimized performance, and meaningful reporting. Security, governance, lineage, and controlled data sharing ensure that analytics remain trusted, compliant, and accessible to the right users. Thank you for watching this video. Stay connected and contact ZoomInData for more content on Microsoft Fabric and DP600. At ZoomInData, we focus on clear, practical learning to build job-ready data skills. Follow ZoomInData for the full series and more insights.